So last time we saw this equation for a simple harmonic progressive wave, right? A wave which travels in positive x direction. So the equation is a sine of kx minus omega t. Okay. And now we also know that what happens in this wave, the particles, they oscillate at their respective positions. Okay. So now what would be the particle velocity? What would be particle velocity? So last time we saw what is wave velocity. V is equal to n times lambda. Okay, n is the frequency, lambda is the wavelength. Now what would be particle velocity? So for that, see, displacement of particle is given by this equation, y is equal to a sine of kx minus omega t. We just need to take derivative of this equation. Okay, so take derivative of this equation. So what do you get? V is equal to dy by dt, and it's equal to, take derivative of this thing. So it is a multiplied by, if we take derivative of sine of this bracket, we'll get cos of this bracket. Okay, but then what is there inside the bracket? So we are taking derivative with respect to t. Okay, we are taking derivative with respect to t. So forget about this x. What will we get? We'll get this minus omega in multiplication. So what we get is minus a omega multiplied by cos of kx minus omega t, right? And therefore what would be the maximum velocity of this particle? So maximum velocity would be equal to a times omega, because the value of cos, it will range between -1 to +1. So the maximum velocity will be equal to a times omega, right? So we had seen this in oscillations. Okay, and it is clear here that particles are doing nothing but they are oscillating about their mean positions. So what would be the maximum velocity? A times omega. Okay, this is clear. Right. Okay, good. Then next, let's talk about the intensity of a wave. Okay, so what is intensity? Intensity is the energy that passes per unit area per unit time. Okay, energy of the wave motion which passes per unit area of the medium per unit time. So then now energy, so we'll give hand wavy expression for the intensity. So since the particles are oscillating, I can just write that energy is equal to half of m omega square a square. Okay, so this is energy of one oscillating particle, right? So it is half of m omega square a square, then divided by so a is the amplitude, therefore for area I will take a prime, right? So it is a prime multiplied by t is time. So then now how can you write the mass? So this is mass of one particle, suppose. Okay, so now if you consider some region of the medium, it will comprise of n number of particles. Okay, it will be made up of n number of particles, right? There will be n number of particles in that region. So simply, how can we write mass? We can just write it as density multiplied by volume. Okay, so then volume can be written as that area of cross section multiplied by the distance through which the wave travels. Okay, so it is a prime multiplied by distance, and a prime would get cancelled out. Okay, then you have s upon t as velocity. Then what do you get is the intensity of the wave is half of rho times v into omega square a square. Okay, the intensity of wave is half of rho times v multiplied by omega square a square, and here an important thing is it's directly proportional to omega square, it is directly proportional to amplitude square, right? The intensity is directly proportional to omega square, directly proportional to amplitude square. Okay, and now see, if you take k times omega square, it will be some kind of a constant. So what you can say is majorly intensity is just equal to k multiplied by a square. Okay, some constant into amplitude square. So intensity is directly proportional to amplitude square is what you need to remember. Okay, and then there is one more thing, that intensity of wave falls off inversely as distance square. Okay, so I is inversely proportional to r square, right? This thing is clear, everyone? Okay, this is simple, right? Okay, then next let us see the principle of superposition of waves. Now this is an important principle. So what does it say? It says that if two or more waves arrive at a point simultaneously, then each wave produces its own displacement, and the total displacement at a point of the medium is vector sum of displacements produced by all waves. Okay, so if two or more waves they arrive at a point simultaneously, okay, so suppose first wave lifts this point, this particle, suppose by this much amount, second wave lifts it by this much amount, then what will be the total displacement of that particle? It would be this much plus this much, so it is this much, right? It's just addition, vector sum. But suppose first wave lifts it by this much amount and second wave pulls it down by this much amount, then what would be the net displacement? So net displacement would be this displacement due to first one minus the displacement due to second one. Okay, actually it's addition only, but displacement due to second one is negative. It's pulling it down, right? So that is the principle of superposition. Each wave produces its own displacement irrespective of the other wave, and the total displacement is just what? The vector sum of the individual displacements. Okay, so then you can say y1 is suppose the first wave, y2 is the displacement, or y1 is displacement produced by first wave, y2 is displacement produced by second wave, the total displacement is just y1 plus y2, right? The superposition gives rise to an interesting phenomenon known as interference. So what is interference? So see, now suppose this is first wave, this is the second wave, and both waves are arriving at a point simultaneously, and suppose the amplitudes and frequencies of both waves are equal. Okay, amplitudes and frequencies of both waves are equal. Then if you add it up, right, so crust of first wave falls on suppose crust of the second wave, trough of the first wave falls on trough of second wave, then what would happen? Then this wave produces a displacement of a, let's say, and this one produces displacement of a, so total displacement of this point would be what? 2a, right? So displacement produced by this one plus displacement produced by this one, it gets just added up, and therefore the resultant wave will look like this. Okay, so this is known as constructive interference. And then if first wave, suppose crust of first wave falls on the trough of second wave, then what happens is there is no displacement. If amplitudes of both waves are equal, the displacements due to first wave they are positive, suppose displacements due to second wave they are equal but they are negative, and therefore if you add up the total displacement would be equal to what? 0. Okay, if you add up the two, the total displacement would be equal to 0, and therefore the resultant displacement would be nothing, right? So there would be no wave. Okay, you have first wave, you have second wave, but addition of the two is no wave. Okay, there is nothing, right? This thing is clear, everyone? Right? Okay, okay, good. So after that, there are some conditions for this interference. So what are those conditions? So first let's see constructive interference. So what should happen for the constructive interference? Crust should fall on the crust, trough should fall on the trough, crust should fall on a crust, trough should fall on a trough, right? So then see, if you imagine the two waves started at the same phase, okay, but now they have traveled some different distance. So what would be the phase difference between these two? So see here, either the phase difference is 0, that means the two waves they start at the same point, this point only, so phase difference between these two would be 0, right? They have just started, or this wave would have started, okay, let's say one wavelength before the first wave, right? So phase difference between these two would be what? So one wavelength corresponds to phase difference of 2 pi. So either phase difference is 0, or it is 2 pi, or it is 4 pi, so on and so forth. So for constructive interference, what is the path difference? The condition for path difference is it is n lambda, right? What is n? 0, 1, 2, 3, so on and so forth. Okay. The condition for the phase difference is n times of 2 pi. Okay. 0 or 2 pi, 4 pi, so on and so forth. Path difference is n times of lambda, phase difference is n times of 2 pi for the constructive interference. And what about the destructive interference? So in destructive interference, the path difference would be equal to, here you can see that suppose both waves started at the same phase, okay, but then this wave started here, this wave started somewhere else, okay, and then to reach at this point, this one covers this much distance. What is this distance? This is lambda by 2, okay, and then crust of this one and trough of this one, they arrive at this point simultaneously, okay. So how much of phase difference would be there? How much of phase difference would be there between these two? So phase difference between them would be equal to pi, okay. So either the phase difference is pi, or it is 3 pi, it is 5 pi, so on and so forth. So path difference would be equal to lambda by 2, or 3 lambda by 2, 5 lambda by 2, that means odd multiples of lambda by 2, and phase difference would be odd multiples of pi, right? So for constructive interference, the path difference is n times of lambda, okay, and what is n? N is an integer, okay, 0, 1, 2, 3, so on and so forth, and phase difference is n times of 2 pi, okay. For destructive interference, path difference is what? 2n plus 1 lambda by 2, this is odd multiple of lambda by 2, n can take values 0, 1, 2, 3, so on and so forth. If n is 0, this is 1 lambda by 2, okay. If n is 1, this is 3 lambda by 2, right? If n is 2, this is 5 lambda by 2. So it is odd multiple of lambda by 2, and phase difference is odd multiple of pi. So 2n plus 1 pi, right? This thing is clear. After that, see, you add these two waves. So this is the equation of first wave, this is the equation of second wave, right? So what would be the equation of the resultant wave? So this is your first wave, this is your second wave, okay. First wave is a1 into sine of kx minus omega t, second wave is a2 sine of kx minus omega t plus phi. So see here, we are taking a simpler case that the wavelength and frequency of these two waves is equal, right? How do you know? You know it from the wave number. Since wave number and omega are equal, so wavelength and the frequency is equal, okay. So then what would be resultant wave? And one more thing, amplitude of these two is different, okay. So resultant wave is just addition of these two, so it is y1 plus y2, okay. So y is the total displacement, resultant displacement, it is just addition of displacements produced by two waves, so it is y1 plus y2, right? And then it is a1 sine of kx minus omega t, that is first wave, plus a2 sine of kx minus omega t plus phi, this is second wave, right? And then what you can do is you can keep a1 sine of kx minus omega t as it is, and you can expand the second term, okay. So see, in these two there is a phase difference of phi, right? The phase of the first wave is kx minus omega t, the phase of the second wave is kx minus omega t plus phi. So there is phase difference of phi, okay. And then next what you can do is you can expand this sine of kx minus omega t plus phi. You can say this is your a and this is your b. So then you have sine of a plus b is sine a cos b. So what is a? kx minus omega t. So sine of kx minus omega t, cos of b, that is cos of phi, plus you have cos of kx minus omega t, sine of phi. So you have two terms and both are multiplied with a2, right? Then next what you can do is you can take sine of kx minus omega t common from this term and this term. So what remains is sine of kx minus omega t multiplied by, you have a1 from this term, then a2 cos phi from the second one, plus you have cos of kx minus omega t multiplied by a2 sine phi from the second one. Okay. So then now see here, this thing can be written as, so this is sine kx minus omega t multiplied by something, multiplied with something, and you have cos of kx minus omega t multiplied with something. Okay. So you have sine of a plus b, sine a cos b plus cos a sine b. So this is sine a, this must be cos of b, right? Cos of some b, okay, or some amplitude multiplied by cos of some b, and this is cos a, so this must be some amplitude multiplied by sine of some b. So let's see. So let's suppose the r is resultant amplitude and delta is the resultant phase. So how do we write this thing as? We write this thing as r multiplied by cos of delta, okay. So this is r multiplied by cos of some b, that b is delta, and this thing is r multiplied by sine of delta, okay. This is r multiplied by sine of delta, right? So we substitute r cos delta. R cos delta equals to a1 plus a2 cos phi, which is this thing, okay, and r sine delta equals to this thing. So if we do that, see, then what do we get? So if you divide this equation by this equation, you get the resultant phase. So tan delta would be equal to a2 sine phi divided by a1 plus a2 cos phi, okay, and therefore what would be delta? Delta would be equal to tan inverse of a2 sine phi divided by a1 plus a2 cos phi, okay. It is a2 sine phi divided by a1 plus a2 cos of phi, right? So if you recall, we had similar formula in addition of two SHMs, right? So this is nothing but addition of two SHMs only, okay. When you are adding two waves, it's like addition of two simple harmonic motions only, okay, because particles are performing simple harmonic motion, right? So this is the resultant phase, and then what would be the resultant amplitude? So that is more important, okay. So here what we did is we substituted this term as r cos delta and this one as r sine delta. So you have sine of kx minus omega t multiplied by r cos delta and cos of kx minus omega t multiplied with r sine delta. So then this is r, you can take common, to sine a cos b plus cos a sine b. So it is sine of a plus b. What is your a? It is kx minus omega t. What is your b? B is delta. So this is sine of kx minus omega t plus delta, right? So you have y equals to r sine of kx minus omega t plus delta. And then now if you square and add this equation and this equation, you get to know what is r. What is r? If you square and add these two, you will get a1 square plus a2 square, okay, plus 2a1 a2 cos of phi, and then if you take square root of that, you get r is equal to square root of a1 square plus a2 square plus 2a1 a2 cos of phi, okay. So in nutshell, if you add two waves having different amplitudes but same frequency and some phase difference between them, so phase difference between them is phi, then what would be the resultant amplitude? The resultant amplitude would be square root of amplitude of first square, okay, amplitude of first wave square plus amplitude of second wave square plus 2 times amplitude of first one into amplitude of second one multiplied by cos of the phase difference between them, okay. What is phi? Phi is the phase difference between them. So cos of phase difference between them. This thing is clear, everyone? Right? Okay. So after that, so this is the resultant amplitude. Next, let us talk about the resultant intensity. Okay. So you can say intensity of first wave would be directly proportional to a1 square. So suppose it is some constant k times a1 square. Okay. Intensity of second wave would be directly proportional to a2 square. So you can say it is some constant k multiplied by a2 square. Okay. So what would be the resultant intensity? Resultant intensity would be directly proportional to resultant amplitude square. Resultant amplitude is equal to r, and therefore you can say the resultant intensity is equal to k times of r square. Okay. Then you substitute r, so it is a1 square plus a2 square plus 2a1 a2 cos of phi, and then see here you can write k times a1 square. You can multiply this equation, okay, this term inside the bracket, all terms inside the bracket with k. So you get k times a1 square plus k times a2 square plus 2 times square root of, here see here you have multiplied with k. Okay, so that k is root k times root k. You can write that k as root k times root k, and this a1 can be written as square root of a1 square. Okay, and a2 can be written as square root of a2 square, and therefore here you have inside this square root k times a1 square multiplied by k times a2 square. And then what is k times a1 square? So it is I1. What is k times a2 square? It is I2. And therefore what you get is resultant intensity is what? It is I1 plus I2 plus 2 times of I1 I2, 2 times of square root of I1 I2 multiplied by cos of phi. Okay, it is I1 plus I2 plus 2 times of square root of I1 I2 multiplied by cos of phi. Okay, this is clear. Right. Okay, good. Then you have I1, suppose I1 is equal to I2 is equal to I, that means both the waves have same amplitude. Then what will happen in that case? So then the resultant intensity would be just equal to I1 plus I2 is 2 times I. Okay, so here you have I times I means square root of I square, so that is I. So you have 2I plus 2 times of I cos phi. Okay, and you can take 2I common out of these two. So what do you get? You get the resultant intensity is 2I multiplied by 1 plus cos phi. Okay, so you get very simple formula. If the amplitude of both waves is equal and there is phase difference of phi between them, so it is just 2I multiplied by 1 plus cos phi. Okay, 2I multiplied with 1 plus cos phi, and then you can substitute phi, the value of phi. So for constructive interference, what is phi? Phi is either 0, okay, or 2 pi or 4 pi, so on and so forth. So you can substitute phi equals to 0, right? What will be cos phi? Cos phi is 1. So then what do you get? The resultant intensity is 2I multiplied with 1 plus 1, that is 2. So it is 4I. Okay, and if there is destructive interference, okay, for constructive interference phi is equal to 0, 2 pi, 4 pi. Therefore the resultant intensity would be equal to 4 times of I. Okay, because cos phi is 1, right? 1 plus 1 is 2, 2 multiplied by 2I is 4I. Okay, so for constructive interference the resultant intensity is 4I, and for the destructive interference it would be equal to 0, because the phase difference would be pi or 3 pi or 5 pi, so on and so forth, right? If you substitute it there, then cos of pi would be equal to what? Cos of pi is minus 1, so 1 minus 1 is 0, so resultant intensity would be equal to 0. Okay, this is clear, the relation between the path difference and phase difference. Okay, so suppose phase difference of phi or phase difference of theta. Okay, suppose two waves have path difference of x and phase difference of theta, then what we can say is this path difference and phase difference, they would be directly proportional to each other. So theta is directly proportional to x. Okay, therefore theta can be written as c times x. Okay, c is some constant, and then you have, suppose when you put x equal to lambda, when part difference is equal to lambda, then we know the phase difference would be equal to what? 2 pi. Okay, so put theta equals to 2 pi here and x equal to lambda, then you get 2 pi is equal to c times lambda. Okay, and then if you divide this equation by this equation, what do you get? Theta by 2 pi would be equal to x by lambda, right? Theta by 2 pi would be equal to x by lambda, and from there you get theta is equal to, okay, theta is equal to what? 2 pi x by lambda, and that means that what is that c? C is equal to 2 pi by lambda, or it is just k, right? So what is theta? Theta is the phase difference. What is x? X is the part difference. And what's the relation between them? Theta is equal to k times x, or theta is just equal to what? 2 pi by lambda multiplied by x. Okay, this thing is clear. Okay, all right. So then, and there is one more thing. So this thing, just remember it as a fact. When a wave passes from one medium to another medium, there is no change in the frequency, but there is a change in wavelength. Okay, when a wave travels from one medium to another medium, then there is no change in frequency, but there is only change in the wavelength. Why is it so? Because the number of oscillations, that is the frequency per unit time, it is property of the source. Okay, so for an example, I am producing this wave, okay, wave on the string, but you have this rope which is connected to a thinner rope, okay, a thick rope connected to a thin rope, and then you are producing waves in this one, right? So when the wave passes from this medium to this is another medium, okay, then what will happen? Its wavelength will change, but number of oscillations, that's the frequency, it is property of the source. Okay, it depends on me how many times I oscillate that rope. Okay, so this is source property. Frequency is the source property and wavelength is the medium property. Okay, so frequency is the property of source and wavelength is the property of medium. This thing is clear? Yes, no? Okay, good. All right, so then let us see some problems based upon whatever we discussed. Let's see this one. A wave traveling in positive x direction with a equals to 0.2 meters per second square, velocity of 360 meters per second, and lambda equals to 60 meter. Then correct expression for the wave is, tell me. Wave is traveling in positive x direction. V is given, okay, lambda is given. And if you look at the options, then there is 2 pi, pi, 2 pi, and there is x by something, x divided by something. So what your equation should be? Y is equal to a sine of, then there is 2 pi, so we can say 2 pi multiplied by nt minus x by lambda. Okay, you can make use of this equation, right? So if you remember this equation, that's well and good. If you don't remember, it's option C. Okay, let's check. So lambda, comparing with this one, lambda is equal to 60, right? If you put lambda equals to 60, okay, 2 pi, then we need n, so this is x by 60. Okay, v is given and lambda is given, so n is equal to v by lambda, and that is 360 divided by 60, so 6. Okay, 6 hertz, that's simple. So therefore n is 6, so this is 60, and what is amplitude? Amplitude is 0.2. so they have made a print mistake here. Amplitude is 0.2 meters. Okay, that's 0.2. Yeah, so it is option, that's correct, it's option C. So then we just saw interference. Let us see some examples based on the interference first. Let's see this one. Two sorry, two periodic waves of intensities I1 and I2 pass through a region at same time in the same direction. Then the sum of maximum and minimum intensities is, okay, tell me, two periodic waves I1 and I2 pass through region at same time in same direction, okay, the sum of maximum and minimum intensities is, what is the maximum intensity? I max. So here you need to remember the formula, right? So maximum would be I1 plus I2 plus you have 2 times square root of I1 I2 and then there is cos of phi here, okay. So for maximum frequency this cos phi would be equal to 1, for minimum frequency cos phi would be equal to minus 1. So let me say this is resultant intensity IR and the maximum would be maximum frequency, maximum, this is the resultant intensity, okay, and maximum intensity would be equal to I1 plus I2 plus 2 times square root of I1 I2, right. So cos phi would be equal to plus 1 and for minimum intensity I mean it would be just equal to what, cos phi would be equal to minus 1. So a negative sign will come here, okay. And then the question is what is the sum of I max and I mean, maximum intensity and minimum intensity. So what would that be? If you add it up, this thing will get cancelled out. So I1 plus I2 plus I1 plus I2 means 2 times of I1 plus I2. Very simple, right? If you add it up, the result is I max plus I mean and it is just 2 times of I1 plus I2. So it is option B. This is clear? Okay, if you remember the formula, it's very simple, right? Okay, good. Let's see next one. Two waves having equation x1 is equal to a sine of omega t minus kx plus phi 1 and x2 is a sine of omega t minus kx plus phi 2. In the resultant wave, the frequency and amplitude remain equal to the amplitude of superimposing waves. The phase difference between them is, okay, tell me what can we do? So what they say is in the resultant wave the frequency and amplitude remain equal to the amplitude of superimposing waves, okay, it's equal to amplitude of superimposing waves. That means R is equal to A, this is given, right, R is equal to A. Then what is R? So we know that R is equal to square root of amplitude of first wave square, that is A1 square you can say, which is A, okay, A square plus 2 times of A multiplied by cos of the phase difference between them, okay. Cos of what is phase difference between them? So phase of first one is phi 1, phase of second one is phi 2, so it is phi 1 minus phi 2, right. So let me just say that this is R and what they are saying is R is equal to A, okay, R is equal to A, right. So then just take square of that, okay, R is equal to A, that means this thing is equal to A. So just take square of this thing, okay, let's take square of this thing. So we get A square plus A square means 2 times A square plus 2 times A square cos of phi 1 minus phi 2 is equal to A square, and then you can move this 2A square on that side. So what do we get? So 2A square cos of phi 1 minus phi 2 is equal to A square minus 2A square is minus A square, and then you can divide this whole thing with A square, okay, You could do that earlier too. Anyways, so if you divide and take this 2 on other side, you get cos of phi 1 minus phi 2 is equal to minus 1 by 2. So tell me, what is the phase difference? What is the angle? Cos of an angle is minus 1 by 2. What is the angle? Yes, everyone. So there is this simple formula. Okay. Cos of pi minus theta is equal to minus cos theta. Right? Okay, you can solve that. So cos of a minus b, you have cos a cos b minus sin a sin b. Using that, if I solve this, cos of pi minus theta, what do I get? I get cos pi into cos of theta minus sin pi sin theta. This thing is 0, sin pi is 0. And what is cos pi? Cos pi is minus 1. Therefore, it is minus cos of theta. Right? Okay, you need to remember this. Okay, so cos of pi minus theta is minus cos theta. Then, if you have cos of which angle is half? Cos 60 is half, right? Cos of pi by 3 is half, and therefore what would be this angle? It is pi minus pi by 3. So it is 2 pi by 3. Okay, so the answer is 2 pi by 3. This thing is clear. Okay, but then you need to remember, so half is what? Cos of 60 degrees, right? So then what would be minus half? It would be cos of pi minus 60 degrees, or 180 degrees minus 60 degrees. Okay, so that is 120 degrees, means 2 pi by 3. Okay, all right, let's see next one. The equations of two waves acting in perpendicular directions are given as x is equal to a cos of omega t plus delta and y is equal to a cos of omega t plus alpha, where delta is equal to alpha plus pi by 2. The resultant wave represents. Tell me. Anyone? Okay, delta is alpha plus pi by 2. This is given. Delta is equal to alpha plus pi by 2. So phase of this one is omega t plus alpha plus pi by 2, and phase of this one is omega t plus alpha. How much is the phase difference? Yeah, it's a circle. Very good. It's a circle. It's very simple. Right, we had seen same question in oscillations. Okay, this is clear. Yes, no. All right, let's solve this. X is equal to a cos of, you have omega t plus delta. What is delta? So delta is alpha plus pi by 2. Okay, so this is cos of omega t plus alpha. This is cos of omega t plus alpha, and here you have cos of omega t plus alpha plus pi by 2. So this thing can be written as what? This thing can be written as, I guess, minus of sine of omega t plus alpha, right? We can check that. Okay, cos of a plus b is cos a cos b. Okay, and cos pi by 2 is 0 minus sin a sin b. Okay, so what is my a? A is omega t plus omega t plus alpha. And what is b? B is pi by 2, sine pi by 2 is 1. So right, that is minus sine of omega t plus alpha. Okay, so that's correct. So it can be written as minus a into sine of omega t plus alpha. So this is your x. What is y? Y is a cos of omega t plus alpha, and then you just square and add these two. So what do you get? So squaring and adding, okay, squaring and adding, you will get x square plus y square is equal to a square sine square of omega t plus alpha plus y square is a square cos square of omega t plus alpha. And then you can take a square common. If you take a square common, what remains is sine square of this thing plus cos square of this thing, that is 1. So that means you have x square plus y square is equal to a square, right? X square plus y square is equal to a square. So this is equation of a circle, and that's why it represents a circle. Okay, this is clear. Yes, Nikita, Selva Kumar.
Clear, sir.
Okay, good. All right, let's see next one. Two waves are passing through a region in the same direction at same time. If equations of these two waves are y1 equals to a sine of this thing, okay, 2 pi by lambda vt minus x, and y2 equals to b sine of 2 pi by lambda vt minus x plus x by x naught plus x naught, okay, then the amplitude of resulting wave for x naught equals to lambda by 2 is, okay, what would be amplitude of resulting wave? So again, this is simple question. You just need to find out amplitude of the addition of two waves. Okay, so amplitude is suppose a, or you can say, let's say r would be equal to square root of a square plus b square, a square plus b square plus 2 times ab multiplied by cos of, what is phase difference? Phase difference is x naught, multiplied by cos of x naught, right? Not x naught. Here we need to, oh, cos of pi, let's say 2 pi. All right, so it is a square plus b square plus 2ab cos of phi, let's say, okay, phase difference is phi. And then what we can do here is we can multiply this term by lambda, okay. So then let's multiply, or let's take lambda inside the bracket. So what do we get? So then we get y2 is equal to b sine of 2 pi multiplied by, you have vt minus x by lambda, okay, and then plus x naught by lambda. So this is the phase difference between the two, right? Actually phase difference would be 2 pi x naught by lambda, not that one also. Okay, so let me just simplify this. All right, so y1 you have a sine of 2 pi by lambda. So let's just multiply this bracket with 2 pi by lambda. So what do we get? So you get 2 pi by lambda times vt minus 2 pi x by lambda. Okay, then we can identify easily what is this thing. 2 pi by lambda is k, okay, then v by lambda gives you n, and 2 pi n is omega t. Okay, so this is a sine of you have omega t minus kx, right? Similarly you can write y2 is equal to b sine of, similar thing you do for this one. So this first term would be omega t, second term would be kx, okay. So you have omega t minus kx, and then you have 2 pi by lambda multiplied with x naught, so plus 2 pi by lambda times x naught. Okay, so then the phase difference between these two is this much, 2 pi x naught by lambda. Okay, so this is your phase difference. And then what would be the resultant amplitude if this x naught is equal to lambda by 2? So by substituting x naught equals to lambda by 2, we get the phase difference. Okay, so pi is equal to 2 pi x naught by lambda, which is equal to 2 pi x naught is lambda by 2, and we need to divide that by lambda. So lambda gets cancelled, then 2 gets cancelled, so phase difference is pi. And therefore what would be the resultant? What would be the resultant amplitude? So r is equal to, we have square root of a square plus b square plus 2ab cos phi, and phi is equal to pi, right? Oh, I wrote pi there itself. This is pi. Okay, phi is equal to pi. And what would be cos pi? Cos pi is sin pi 0, right? Cos pi is minus 1. Okay, so it is just equal to square root of a square plus b square plus 2ab into minus 1, that is minus 2ab, and square root of that is just what? That is a minus b square, right? This is a minus b square inside a square root. So that is a minus b, but you don't know whether a is greater or b is greater. So the answer would be a minus b absolute sign. Okay, this thing is clear? Yes, no? Let's see this one. In a sinusoidal wave, the time period for a particular point to move from maximum displacement to zero displacement is 0.170 seconds. The frequency of the wave is, tell me. In a sinusoidal wave, the time required for a particular point to move from maximum displacement to zero displacement is 0.170 seconds. The frequency of the wave is. Okay, how much time is required to go from maximum to zero displacement? That's simple. It's t by 4, right? Okay, particle, suppose it oscillates between these two ends, minus a and plus a. Okay, so to go from here to here, maximum displacement to zero displacement, how much of time is required? It's t by 4. Okay, right? Because to complete one oscillation, which is from here to here to here, it requires time period t. So time taken to go from here to here is just t by 4. So what's given here? T by 4 is equal to 0.17. Okay, and therefore what would be t? T just equal to this thing multiplied by 4. Okay, it is 0.68, right? 0.68 seconds. And therefore what would be frequency? Then there is nothing, it's 1 by t only. Okay, so 1 divided by 0.68. Okay, or nearly you can say this is 3 by 2, sorry, 2 by 3, this would be 2 by 3, right? Nearly equal to 2 by 3, you can say 2 by 3 would be 0.66, no? Okay, so if you take a reciprocal of that, reciprocal of 0.66 recurrent, it would be 3 by 2. 3 by 2 means 1.5. So nearly 1.5 means this is the answer, 1.47. Okay, so it is option C. This one was simplest, right? It's simple or not simple? Okay, let's see next one. The equation of sound wave is this one. The wavelength of this wave is, okay, again a simple question. So this is the equation and this is amplitude then we just need to compare this equation with what? Y is equal to a sine of kx plus omega t. So in what direction is it traveling? Positive x direction, negative x direction? Positive x or negative x? Negative x, right? It's negative x. Okay, good. So then you have comparing with this one. Comparing, you get k equals to what? K is equal to 62.4, that is 2 pi by lambda is equal to 62.4, right? And then I guess yeah, you can write pi equals to 3.14. okay, if you multiply that with 2 you will get 6.28, okay, and therefore lambda would be nearly, so this is 6.2 is equal to 62.4, this is 6.28 is equal to 62.4 lambda, and therefore take this 62.4 on other side, so therefore lambda is 6 divided by 60 nearly, okay, so it's 0.1, okay, but unit is not given, so it's 0.1 unit. It is option C, right? This is simple. Yes, no, right. Let's see next one. Two sound waves having phase difference of 60 degrees have part difference of. So this is a direct question based upon the formula of phase difference and part difference. So you have phase difference theta is equal to 2 pi x by lambda, okay. You want part difference, so part difference would be equal to what? X is equal to lambda by 2 pi multiplied with theta, okay. Just move these things on other side. We want x, so lambda and 2 pi goes on other side, so it is lambda by 2 pi multiplied with theta. So it's lambda by 2 pi multiplied with theta. What is theta? Theta is 60 degrees, but then we need to convert it to radians. So 60 degrees means pi by 3 radians, right? So it is pi by 3 radians, then pi and pi gets cancelled out, so it is lambda divided by 2 times 3, 6, okay. So phase difference is just part difference is just lambda by 6, right? This is simple. All right, let's see next one. The frequency of sinusoidal wave y is equal to, okay, this is very simple question. Again, comparing with y equals to a cos of, here we have cos, okay, 2 pi nt plus kx. What do we get? 2 pi n is equal to 2000, right? Okay, it is omega t, but I directly wrote 2 pi n. 2 pi n is equal to 2000, and therefore what would be n? It's 2000 divided by 2 pi. We want frequency, right? 2000 divided by 2 pi means 1000 by pi. So it is option D, right? So this is very simple. Okay, let's see next one. Equation of a progressive wave is given by this thing, where y, x are in centimeter and t is in seconds. Then which of the following is correct? Okay, so here they have given v, lambda, a and f. That means velocity, wavelength, then what? Amplitude and frequency. So different things are given. Okay, amplitude is 4, right? Amplitude is 4, but what is that? It is in centimeters, right? So 0.04 meters, and they say 0.04 centimeters, so this is incorrect. Okay, the other things we need to check. So again, let's compare this one. So let's rewrite this as 4 sine of, take that pi inside, okay. So it becomes pi t by 5 minus pi times x by 9, pi times x by 9, okay, plus pi by 6, okay. So therefore, what would be your omega t or 2 pi nt? So 2 pi nt would be equal to pi t by 5, and then you can cancel out tt and pi pi. So n is equal to 1 by 10. You get n equals to 1 by 10. Right, that's correct. This is 2 pi nt is equal to pi t by 5. Pi pi gets cancelled. N is equal to 1 by 10. Okay, so frequency is 0.1. Right, so that's also not there. Then we need to check lambda. Let's check lambda. So comparing this one with what? 2 pi x by lambda. So we get 2 pi x, that is k times x, okay. 2 pi x by lambda is equal to pi x by 9. So then what do we get? Pi x gets cancelled out, and lambda equals to, take the 2 on other side, 9 times 2 is 18. Okay, that's correct. So lambda is equal to 18 centimeters. So that is the answer, right? So it's option B. Okay, this is clear. This is just comparison, right? Okay, this is simple. Yes, no. All right, let's see next one. Then the equation of a simple harmonic progressive wave is given by this thing. Find the distance between two particles having phase difference of pi by 3. Okay, so you want distance between two particles having phase difference of pi by 3. So first of all, what we'll do is we'll take this equation and find out the wavelength. So it is a sine of 100 pi t minus 3x, okay, and then compare this with y equals to a sine of omega t, or let's say 2 pi nt minus kx, or let's take omega t only, right? And we want wavelength only, so k is equal to 3. Let's use that only. K is equal to 3, that is 2 pi by lambda equals to 3. So what is lambda? This implies that lambda is equal to 2 pi by 3. Okay, so this is very simple. And then what do you have? So phase difference is pi by 3. What would be the path difference? Okay, distance between two particles having phase difference of pi by 3. So again, theta is equal to, you have 2 pi x by lambda, right? And oh, we actually didn't need to find out lambda, right? We could just substitute k. So okay, simpler way to do this, theta is just equal to kx, right? No need to do 2 pi x by lambda. We have theta is equal to k times x. So put k equal to 3, okay. So theta is equal to 3 times of x, and what is the phase difference? It is pi by 3. So put it over there. So it's pi by 3, and then we can get x. So move that 3 on other side, you get x equal to pi by 9 meters. Okay, so that is the answer, option A. So this is clear. Yes, no. Okay, there is no need to find out lambda, and use this formula. Okay, 2 pi x by lambda, theta is equal to 2 pi x by lambda. What can we do is we can just use theta equals to kx, because 2 pi by lambda is what? It is just k. Okay, all right, and it will save us some time too, right? Okay, let's see next one. 2 points on traveling wave having frequency of 500 hertz and velocity of 300 meters per second are 60-degree out of phase. 2 points on a traveling wave having frequency of 500 hertz and velocity of 300 meters per second are 60-degree out of phase. Then the minimum distance between 2 points is, actually there would be, yeah, minimum distance between 2 points. That's correct. Okay, so just find out, see, they have velocity, wave has velocity of 300 meters per second and frequency is given 500 hertz. So from that just find out wavelength. Okay, so wavelength is v by n, that is 300 by 500 or 3 by 5 in meters, right, because this is given in meters per second. And then 2 points are 60-degree out of phase, means theta is equal to 60 degrees. Okay, that is pi by 3. And we want the distance between these 2 points. So x is equal to, or we have theta equals to 2 pi x by lambda, because here we have lambda, so we'll make use of this formula 2 pi x by lambda. Okay, so x is equal to lambda by 2 pi multiplied with theta, so that is lambda by 2 pi into theta is pi by 3, that pi and pi gets cancelled, so it is lambda divided by 6. Okay, and lambda is 3 by 5, substitute that, it is 3 by 5 divided by 6. So what's that? 6 pies are 30. Okay, 3 by 30 is 0.1, right? So the answer is 0.1 meters. This one is clear. Okay, everyone. All right, so questions are similar, right? Okay, then let's see next one. A progressive wave moving along x-axis is represented by this thing, the wavelength lambda at which the maximum particle velocity is 3 times the wave velocity. Okay, so this is little different. The maximum particle velocity is 3 times the wave velocity. Alright, so what do we have? We have y equals to a sine of 2 pi by lambda into vt minus x. Okay, and here see, we want maximum particle velocity, so that would be a times omega. Okay, but before that, now what we'll do is I will just substitute x equal to 0 just to simplify this. Okay, so if I take x equal to 0, what do I get? I get a times sine of, right, see, because particles at all positions will oscillate with the same frequency, right, and their maximum velocity would be equal. So if I take x equal to 0, it makes no difference. Okay, then I have a sine of this thing. What is this thing? Just multiply it out. So it is 2 pi vt by lambda. Okay, then take its derivative. Then what do you get? dy by dt. And what is this? This is the velocity of particle, vp. Velocity of particle is equal to dy by dt, and it is equal to a multiplied by, now derivative of sine is cos. Okay, you have sine of this bracket, then derivative would be cos of the bracket, but multiplied with what? Multiplied with this thing, because it's not t, we are not taking derivative of sine t, we are taking derivative of sine of this thing multiplied with t. Okay, so that thing will come in multiplication. Okay, right, so it is a times that thing means 2 pi v by lambda, okay, times cos of 2 pi vt by lambda. And what is the maximum velocity? Maximum velocity of the particle. So Vp max would be equal to, so this cos term will have maximum value of 1. So it is a multiplied with 2 pi v by lambda. And what's given in the question? That the maximum particle velocity is 3 times of wave velocity. Then that's simple. So the question says that this maximum particle velocity is equal to 3 times of wave velocity. So this is 3 times of v. So it is a times 2 pi v by lambda is 3 times of v. V gets cancelled, okay, and we want that wavelength. So V gets cancelled, take that 3 on that side, lambda on this side. So we get lambda equals to 2 pi by 3 times a, right? 2 pi by 3 times a. So that's the answer. It is option D. Okay, this one is clear. Yes, everyone. Right. Okay, good. Let's see next one. If the amplitude of sound is doubled, if the amplitude of sound is doubled and the frequency reduced to 1/4, okay, amplitude is doubled, frequency is reduced to 1/4, the intensity of sound at the same point will be, tell me. Amplitude is doubled, frequency is reduced to 1/4. This is simple. Intensity is directly proportional to what? Omega square a square. Okay. So I prime would be proportional to what? So here you can say it is k times of omega square a square, and I prime would be k times of omega prime square a prime square. What is done with the amplitude? Amplitude is doubled and frequency is reduced to 1/4. So we can just substitute that. This is k times of omega by 4 square multiplied with amplitude square, so that is 2a square. So this will be 4, okay, 4 times a square, and this thing will be omega square divided by 16. Okay, 4 by 16 is 1/4, and therefore this thing will be equal to 1/4 of k omega square a square, and that is 1/4 of I. Okay, it is 1/4 of I. So the intensity decreases, okay, by the factor of 4, right? Intensity decreases by the factor of 4. Okay, this is clear. Let's see next one. Velocity of sound waves in air is 330 meters per second. For a particular sound wave in air, part difference of 40 centimeters is equivalent to phase difference of 1.6 pi. The frequency of the wave is, tell me. Velocity is given, part difference is given, phase difference is given. That means by using the part difference and phase difference, you can find out lambda. Okay, and once you find out lambda, then you can very easily find out the frequency. Okay, so very simple. Okay, let's work it out. V is equal to 330 meters per second you have, and then part difference is 40 centimeters, so x is equal to 40 centimeters, and phase difference is 1.6 pi. Okay, so let's convert this to meters because velocity is in meters per second. Okay, so it is 0.4 meters, right? And theta is equal to 1.6 pi, and we know theta is equal to what? It is 2 pi x. This 2 pi x by lambda, and that is 1.6 pi. What is x? So x is 0.4. Okay, x is 0.4. So it is 2 pi multiplied with 0.4. 2 pi times 0.4 divided by lambda is 1.6 lambda, sorry, 1 pi 6 pi. Pi and pi gets cancelled. What remains is take lambda on that side, and this thing is 0.4 times 2 is 0.8. 0.8 is equal to 1.6 lambda. Okay, so lambda is equal to, we have 0.8 divided by 1.6, and that is, what's that? It's 1 by 2, right? 0.5 we can say. And then what's the frequency? So n is equal to v by lambda. So that is, v is 330 and lambda is 0.5. Okay, so v by lambda is 660. Okay, 660 hertz, right? So very simple question. Okay, but there are a lot of questions. All right, let's see next one. So this is just sample of the number of questions that were asked based on these topics. Okay, anyways, let's see this one. Our transverse wave is represented by this thing. For what value of lambda, the maximum particle velocity is equal to 2 times the wave velocity. So now, just now we solved this kind of question. Okay, so question is, the maximum particle velocity is 2 times of wave velocity. So again, in this kind of question, what you do is put x equal to 0 first. Okay, if you want to find out maximum particle velocity and wave velocity, relate them. Put x equal to 0, so it simplifies. You get y equals to y naught sine of 2 pi by lambda times vt. Okay, and then just take derivative of that. So when you take derivative of that, dy by dt. So now here, see, if you practice, you will come to know that what would be the maximum velocity. Vmax would be just equal to velocity of particle maximum would be y naught multiplied with this term, because this term is omega, right? This term is omega, right? Yes, no? Okay, it is, if you drop x, term containing x, that is kx. Okay, what remains is term containing t, so that is omega t. So this is omega. Okay, so then when you take sorry, when you take derivative, what will happen? It will be a omega times of something, and therefore what would be the maximum velocity? It is a times omega. Here a is y naught, so it is y naught times omega. Okay, and omega is this term, right? So directly you can say Vp max is equal to y naught multiplied with omega, that is y naught multiplied with 2 pi v by lambda, right? Okay, or shall we take derivative? This is Vp, dy by dt is velocity of particle. Okay, so that is y naught multiplied with this term 2 pi v by lambda times cos of the same term 2 pi v by lambda times t, and then for maximum velocity this term would be equal to 1, cos would be 1. So again it is this thing only, right? And what's given? So this thing is equal to 2 times of the wave velocity. So this is equal to 2 times of wave velocity, right? So this is equal to 2 times of wave velocity. 2v is equal to y naught multiplied by 2 pi v by lambda, and then vv gets cancelled, and you want lambda. Take lambda on that side, this 2 on this side, or already 2 gets cancelled. So lambda is equal to just pi times of y naught, right? It is just pi times of y naught, right? Lambda is equal to pi times of y naught. Okay, so that is option D. This is clear. Okay, So in this kind of question, what you can do is just put x equal to 0, then whatever remains is, okay, whatever remains is this thing, and in this thing, okay, is omega, 2 pi, whatever it is, okay, the term in multiplication with t is omega. And then what is maximum particle velocity? It is this term, amplitude multiplied with omega. That's it, right? You don't need to take derivative and all, okay. Anyways, so let's see next one. The equation of a wave is represented by this thing, then the velocity of wave will be, this is simple, okay. So these are some questions left from the last class, okay, that we are taking. Anyways, okay, tell me what is this? So compare this with y equals to 10 raised to minus 4 sine of, okay, compare this with y equals to a into sine of omega t minus kx, right? So what do you get? You get omega equals to 100, okay, and k is equal to, it's in meters, k equals to 1 by 10, okay, k equals to 1 by 10. And then you know v is equal to omega by k, right? This direct formula, you know, v is equal to omega by k. Put omega equals to 100, k equals to 1 by 10, take the 10 in the numerator, so you get 1000, okay, 1000 meters per second. So that's the answer, okay. So you don't need to find n and lambda, you can directly make use of this formula, right? It will save some time. This is clear? Okay, all right, good. Let's see next one. A point source emits sound equally in all directions in non-absorbing medium. 2 points P and Q are at distance of 2 meter and 3 meter respectively from the source. The ratio of intensity of waves at P and Q is, tell me. Anyone? Option C? Yeah, that's correct. Because intensity is inversely proportional to distance square, right? Intensity is inversely proportional to distance square. So you can say I1 by I2 is just equal to R2 by R1 square, and that is equal to, what is R2? R2 is 3, R1 is 2, so 3 by 2 square, so that is 9 by 4. Very simple, right? Correct, Yamini. This is clear? Others? Okay, very good. Let's see next one. A transverse wave propagating along x-axis is represented by this thing, where x is in meters and t in seconds. The speed of wave is, okay, tell me. So these are leftover questions that are scattered here and there. Anyways, so again you can make use of, okay, y is equal to a sine of, compare with this one, kx minus omega t plus phi, okay, but we don't need phi. So k is 0. You get k equals to 0.5 pi, right, comparing with this one, and omega is just equal to 4 pi, and v equals to omega by k. There is nothing in the question, right? Option A. Selva Kumar says option A. Did somebody else is also answered? Alright, so omega is equal to 4 pi divided by, you have 0.5 pi, right, that's correct. Pi gets cancelled, 4 divided by 0.5. So it's 8 meters per second. Yeah, very simple. Okay, good. So now we can solve these kind of problems. And then a transverse wave is represented by y equals to a sine of omega t minus kx. For what value of wavelength is the wave velocity equal to maximum particle velocity. Okay, so again that's same, right? So for what value of wavelength is wave velocity equal to maximum particle velocity? Okay, so what is wave velocity? Wave velocity, let's say it is v is equal to maximum particle velocity, vp max, right? So here you don't need to do anything. Vp max is just a times omega. It is given in the standard form. And what is v? V is equal to n times lambda. Okay, so that's very simple question. N times lambda is equal to a times of 2 pi n, right? N gets cancelled and you have lambda equals to 2 pi a only. That's it. Lambda equals to 2 pi a. Okay, so it is option C, right? Okay, this is simple. Okay, so this question has been repeated and it was asked recently also. Okay, let's see this one. Sound waves travel at 350 meters per second through warm air and at 3500 meters per second through brass. Okay, the wavelength of a 700 hertz acoustic wave as it enters brass from warm air is. Okay, tell me. Sound waves travel at 350 meters per second through warm air and at 3500 meters per second through brass. Okay, so wavelength of 700 hertz acoustic wave as it enters brass from warm air is. That's simple. So see what we'll do is we have wavelength, no, we have the frequency. So n is equal to 700 hertz in one medium. In what medium? In air. Okay, so you have v is equal to n times lambda 1. Okay, and then you find lambda 1, right? Actually don't even need to do that. I'm sorry, because they don't want us to calculate the wavelength. Okay, what's given? Decreases by factor of 10, increases by factor of 20, increases by factor of 10, decreases by factor of 20. So the answer is, see, speed in air is 350 meters per second, speed in the brass is 3500 meters per second. Frequency does not change. We know that when a sound wave or any wave travels from one medium to another medium, what changes? Wavelength changes, frequency does not change. Okay, frequency remains constant. So if frequency remains constant and speed increases by the factor of 10, what does it mean? The wavelength increases by the factor of 10. That's it, right? Speed becomes 10 times, means wavelength becomes 10 times. Is this thing clear? So it increases by the factor of 10. You don't need to solve anything. Yes, everyone? Okay, good. All right. So when a wave enters from one medium to another medium, frequency remains constant. What changes? Wavelength changes, and you know v is equal to n times lambda. N does not change, but if v increases 10 times, means lambda increases 10 times. Okay, so here v is increasing 10 times, means lambda is increasing 10 times, right? So that's the answer. All right, so let us first discuss this thing. Okay, so speed of a transverse wave in a string. Okay, so now let's see speed of a transverse wave in a string. So here we have direct formula for this. So suppose this is a string which is tied to a rigid support and some weight is hung, okay, to this other end of the string. And then what you do is you pluck that string and release, then a wave will travel, okay, wave will be formed which will travel from, let's say you pluck it over here somewhere, so from one end to another end. Or you can think of it like this. So there is a string, a long string, okay, two friends stretch it, but in that case you don't know what would be the tension in the string, okay, you are just stretching it, you are not measuring the tension, and one friend makes it oscillate, so wave will travel from one end to another end, so there would be some tension in the string. So now the speed is equal to, speed of the transverse wave in a string is equal to square root of t by mu, okay, it is square root of t by mu. So see here, now it depends on two things. One is the restoring force, okay, the restoring force, or you can say the elasticity, okay, elastic property of the medium, and it depends on the inertia of medium, okay. So speed depends on two things. One is the restoring force, that is tension in the string, or it's the elastic property of the medium, and second thing is inertia, okay. So now see how fast it will be, okay, which term will come in numerator and denominator. So see, some factor of t by mu will come. Now what will be that power? Okay, what is mu? Mu is the mass per unit length. Okay, what is mu? Mu is the mass per unit length. Okay, more is the restoring force, faster it will come back. That means faster the wave will travel, right? More is the mass, then longer it will take. Okay, so therefore it's directly proportional to some power of t and it's inversely proportional to some power of mu. So the derivation it's not there, but we can understand it intuitively why t is in numerator and why mu is in denominator. Okay, so t is tension in the string, mu is mass per unit length of the string. So then if we do dimensional analysis, we can find out v is equal to something, some constant multiplied by square root of t by mu. What is t? T is the tension and mu is mass per unit length. And we need to remember this formula. Okay, right, this thing is clear everyone. V is equal to the speed of transverse wave in a string is equal to square root of t by mu, okay, where mu is what? Mass per unit length, and then if m is the mass of the string, L is the length of string, then you can put that, you get mu is equal to m by L. You get what? Mu equals to m by L. Then you put it over here. So what do you get? V is equal to square root of t times L by m. Okay. And then how can you write mass? Mass can be written as density into volume. Okay. Mass can be written as density multiplied by volume. Right. And the volume can be written as area of cross section. Okay. So suppose this is a string, then volume can be written as area of cross section multiplied by the length, and therefore, okay, mass is density into volume, volume can be written as area into length, length and length gets cancelled out, okay. Then you have, see, tension per unit area. So what's that thing? It's a stress, longitudinal stress produced in the string, right? Tension per unit area is the longitudinal stress produced in the string, and you have rho in the denominator. So the speed of transverse wave on a string is equal to what? Square root of longitudinal stress divided by the density. This is another formula that you need to remember. After that, let's talk about the longitudinal waves. So their speed in solids is given by, see, as we discussed, the speed depends on what? The restoring factor, or you can say the elasticity. Okay, elasticity is what? The restoring force generated per unit area, okay, that is stress divided by strain, okay, and it depends on the elasticity, or you can say the restoring factor, and it depends on what? Inertial factor, okay. The longitudinal waves, they will produce the compressions and rarefactions in the bulk of medium, okay. So here, now here we took mass per unit length, because these waves they travel in some length. Okay, here we need to consider the volume. Okay, here we need to consider mass per unit volume, because the longitudinal waves, the compressions and rarefactions, they will be produced in some volume, right? So we need to consider inertial factor as mass per unit volume, means what? Density. Okay, so here the restoring factor would be elasticity or modulus of elasticity, you can say, and the restoring factor would be what? Modulus of elasticity, and the inertial factor would be what? Inertial factor would be density, just because the compressions and rarefactions are produced in some volume. Okay, so it's good to take mass per unit volume. This thing is clear? Yes, no? Okay, then now you need to remember this formula, okay, because there is no derivation, that the speed of longitudinal waves in solids would be equal to, it is just the square root of Young's modulus to the density. Okay, speed in solids is just Young's modulus divided by density. Okay, but speed in fluids would be bulk modulus divided by density. So the reason to that is, okay, reason to that is because there is large change in the density. See, the speed, the density of solids won't change when the longitudinal waves they travel through solids. Okay, but density of the liquid or a gas, it will change. Okay, it will change very fast, right? If you take for an example a rarer medium like gas, then what will happen? So in compressions density is very high, in rarefactions the density is very low, right? So that won't happen in case of solids. So solid molecules, okay, they will not gather with very high density in some volume and won't get separated that fast in rarefaction, you can say. Okay, so the density of solids doesn't change much. Okay, but here the modulus of elasticity that you take is bulk modulus, because there is huge change in density, right? So speed in fluids is given by V is equal to square root of bulk modulus divided by rho. Okay, it is given by square root of the bulk modulus divided by rho, right? And then after that there is entry of our hero, that is Newton. Okay, so he comes everywhere. So Newton was the first person to give the formula for the velocity of sound in air. Okay, and see, his formula is square root of p by rho. Okay, square root of p by rho. So let me explain this and then I will tell you what kind of question can come based on this topic. Okay, so what is Newton's formula for the speed of sound in air? It is square root of p by rho. So see, according to Newton, the propagation of sound through the air is an isothermal process. Okay, according to him, the propagation of sound through air is an isothermal process. That means there is no change in temperature. Okay, and isothermal bulk modulus is given by pressure. Okay, isothermal bulk modulus is just equal to what? Pressure of the air. Okay, so therefore the speed is equal to what? Square root of bulk modulus divided by rho. And what is bulk modulus? Bulk modulus is pressure. So therefore Newton's formula is V is equal to just square root of p by rho. Okay, so now do you think there will be change in the temperature when sound travels through air? So it's not an isothermal process. But first of all, why would there be any change? Okay, why would there be any change? So see, when sound travels through the medium, there are compressions and rarefactions produced in the medium. So what happens in case of compression? Particles collide onto each other. So when particles collide, what will happen? So some heat is produced. Why? Because energy of some particle is transferred to other particles. So that is heat, right? We have studied what is heat. We have studied in kinetic energy of gases that heat is nothing but its energy of the particles, right? Kinetic energy of particles. Okay, So when particles, see, they collide onto other particles, some energy is transferred, so some heat is produced. Okay. So now in case of rarefactions, what will happen? So in rarefactions, particles will go away from each other and they are also in contact with the surrounding medium. So heat gets dissipated in the surrounding medium. So according to Newton, the heat produced in case of compression gets dissipated to the surrounding medium in the rarefaction, and that's why the temperature does not change. Okay, so heat is not trapped in the region in which the wave is traveling. Okay, but for this to happen, the production of compression and rarefaction must be very slow, right? Because the heat should get enough time to get dissipated to the surrounding. Okay, to establish the equilibrium, you will need some time. Okay, we have studied this. If it is a quasi-static process, then the system, that's the region in which what the wave is traveling, and the surrounding, okay, they are in equilibrium, right? If it is a slow process, but this thing doesn't happen that slow. Okay, so frequency of sound is several hundred hertz, and that means in 1 second hundreds of compressions and rarefactions are produced. So this happens very fast. So the heat that is developed in case of compression doesn't get enough time to get dissipated to the surrounding. Okay, and that's why the heat is trapped in that medium. Okay, that region of medium we can say, and approximately this is an adiabatic process. Okay, and it was pointed out by Laplace. So Laplace says that it's a fast process, so the heat doesn't get enough time to get dissipated to the surrounding, and that's why it is what, an adiabatic process. It cannot be isothermal. Okay, and then he found that the adiabatic bulk modulus of air is what? It is just gamma multiplied by pressure, and we know what is gamma. Gamma is the ratio of specific heat specific heat capacities. Gamma is the ratio of the molar heat capacities or specific heat capacities, right? So it's Cp by Cv. Cp is to Cv, and then if you substitute that formula, you get bulk modulus equals to what? Gamma times P, and then speed of sound or velocity of sound in air is square root of gamma times P by rho. Okay, this is the Laplace's formula. Actually, this is Laplace's correction to the Newton's formula. Is this thing clear to everyone? So, of course, this is a wrong formula. So, we cannot make use of this one. Okay. So, suppose pressure is given, then whether it's air is given. Okay. What I am saying is, suppose the pressure is given, density of the air is given, and gamma is also given. Then, of course, we will make use of the another formula, the second formula, right, to find out speed. Okay, or speed is given and we are asked to find out pressure, we will make use of that formula. But then what is the importance of this one? Newton's theory. So there can be a question based on this, like this, that Newton assumed that the traveling of the sound in air, it is isothermal process, adiabatic process, whatever the other processes, right? So the answer would be isothermal process. Okay, then second question, the Laplace thought or assumed that the propagation of sound through air is isothermal process, adiabatic process, okay, or something else. So it is an adiabatic process, right? And actually this propagation of sound through air is what? Again, okay, they will not mention the name of Newton, they may not mention the name of Newton or name of Laplace. They can just ask the traveling of sound through air is isothermal, adiabatic, something else process. Okay, so answer would be adiabatic process. Is this thing clear? Yes, no? Okay, good. So then let us just quickly discuss. Okay, so let us just quickly discuss the factors affecting the speed of sound in air. Okay, so for 1 mole of gas, what can I say? that density is equal to what? We have density is equal to mass upon volume, right? So you can substitute that here. Okay, see, you have V equals to square root of gamma times P by rho. Okay, and then you have density equals to mass by volume. Okay, so then what you can do is, here you can substitute mass upon volume. Volume will go to the numerator, and here you get PV, right? Here you get what? PV. So then at some constant temperature, PV can be written as nRT. For 1 mole of gas, it can be written as what? Just RT. So you get another formula, V is equal to square root of gamma times RT by M. M is the molar mass. Okay, M is what? It's the molar mass, right? For 1 mole of a gas. If there are n number of moles, then there will be mass of n number of moles, right? Still this formula can be used, right? There would be mass of n number of moles and n in the numerator. That's the same thing. Okay, so it is square root of gamma RT by M. And then now what would be effect of temperature? So if temperature changes, then what will happen? The speed will change, speed of sound in air will change. Okay, so speed is just directly proportional to root of temperature. That's one thing. Then what is the effect of change in pressure? If the pressure changes, then there would be no change in the speed of sound in air if temperature doesn't change. Okay, because what can happen if pressure changes, which actually changes in compressions and rarefactions too, right? But then what will happen? See, pressure increases, volume might decrease. Okay, pressure decreases, volume might increase, and this product of PV might remain constant. So this product is more important. Okay, so because you have this formula, if you just take the temperature, okay, R is a constant, M, you take some air, okay, some fraction of air, you can say, or sample of air, then M would be a constant, gamma would be a constant for that air. What can change? Temperature can change, then there would be change in speed. But if pressure changes, then, and there is no change in temperature, will the speed change? The speed will not change, right? This thing is clear. Okay, so if the temperature remains constant, there won't be any change in the speed of sound in air. If pressure changes, okay, if pressure changes, and then next thing is humidity. So now we know that the moist air is less dense compared to that of the, if humidity increases, density decreases, right? So if humidity increases, density decreases. Okay, right? So density decreases means what will happen? The speed will increase. Okay, if density decreases means the speed of sound will increase. This thing is clear. So density decreases means I can say V increases. Okay, right everyone? All right, good.